The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so for part D, we just need to complete the square. So if you remember this from college algebra or pre-calc, when you complete the square, we're just trying to find an easier way to express a non-factorable quadratic equation like this one. So what you want to notice is you always want to figure out what is the constant that I would need to make this a perfectly factorable quadratic. And since we have x squared minus 2x, you always take half of the coefficient on x, in this case half of negative 2, negative 1, and square it. We would need a 1. X squared minus 2x plus 1 factors perfectly. We have plus 2, so let's just say we have plus 1 instead. This part right here factors just fine, and we have an extra plus 1 left over. So this is x minus 1 squared, and we have plus 1. So this right here is the exact same thing as this, except this is nicely factorable, or it's nicely factored. So let's use that to evaluate letter E, which is to do the integral of 1 over this function. That's a misprint on the test. It should be x squared minus 2x plus 2, the same thing we just did. So if we're going to integrate 1 over x squared minus 2x plus 2, we want to put it in this form. So instead, we're going to say this is the integral dx, of course, 1 over x minus 1 squared plus 1. And this form you should recognize as an arctangent. So because x and x minus 1 have the same derivative, we don't really have to do any substitution here because our integral is not going to change. But remember that 1 over x squared plus 1 is the arctangent form. We just have x minus 1 instead of x. So our antiderivative here is going to be arctan of, in this case, we just have x minus 1, because that's what's in there instead of x, plus c, and that's our definite integral. So we want to use this plus all the stuff we did in the previous 3 parts of the problem to evaluate the integral of our main fraction in the problem, the one that we did partial fraction decomposition on. So we want to do the integral of x plus 2 over x cubed minus 4x squared plus 6x minus 4. Okay, so recall from the previous parts, we did the partial fraction decomposition of this, and we got that this integral is going to be of the 2 fractions. It's going to be of, so we had one that had a denominator of x minus 2, another that had a denominator of x squared minus 2x plus 2, which is what we were just doing up there. So we have this from the previous part of the problem. Okay. So we need to integrate this, and we're going to have to treat these fractions separately. You should recognize that this first one is just going to be a simple logarithm. We're going to have to deal with the second one, though, as it's not going to be quite as simple. So first, let's just deal with the first part, the integral of 2 over x minus 2. That's just 2 times 1 over x minus 2. X minus 2, again, it has the same derivative as x, so you don't need to do u substitution or anything like that. So our first integral is just going to be 2 ln of x minus 2. Because we have basically 1 over x minus 2 times 2. That's going to be this one. Now this one we're going to have to do a little bit more work with. Now, one thing you should always recognize in these problems is that if you have a degree, if you have a polynomial that's 1 degree higher in the bottom than it is in the top, it has the makings of being an ln. Remember, but it's only going to actually be an ln if the numerator is the derivative of the denominator. So let's see, what would the derivative of this denominator be? It would be 2x minus 2. So we want our numerator to be 2x minus 2, because if we had that over x squared minus 2x plus 2, that would be just a regular ln, and we'd be done. So we don't quite have that. So what we can do, though, to try to make it as close as possible is to factor out the negative. So this is what we want right here. So let's deal with the top here to try to get it to be 2x minus 2. If we factor out the negative, we're going to have 2x minus 1. That's pretty close. And what we could do with this negative is instead just subtract this entire integral. So really now we have 2 ln of x minus 2, in other words, what we got from this one, minus the integral of 2x minus 1 over x squared minus 2x plus 2. Now we're trying to get this to be 2x minus 2 in the top, not 2x minus 1. So what do we need to do? We need to just subtract 1 and add 1. So what we can do here is just say 2x, this is the same thing as 2x minus 2 plus 1. And you might be saying that's kind of strange, like it's pretty trivial to do that. It is, but it actually helps. And remember, you only really want to do that on the numerator because now we can split this into two different fractions and everything will be perfectly fine. Let me bring the work over here. So again, I'm not going to keep rewriting this first part of the integral. We already have that, but let's work with this. So now our integral becomes 2x minus 2 over x squared minus 2x plus 2 plus 1 over x squared minus 2x plus 2 dx. So when you have multiple terms in your numerator, you can put each one or any group of them over the denominator like this, as long as you keep your signs correct and everything. So this is perfectly fine, and now these are both simple to do. In this case, the top is exactly the derivative of the bottom. That automatically means this is an ln. You can see that, of course, by u substitution if you want to do that out. This part right here ends up being ln of x squared minus 2x plus 2. This integral we had just done from part E, and we got this. So we have plus arctan x minus 1. So the last thing we need to be careful of is we were actually subtracting this entire integral from our first one. So our final answer here is going to be 2 ln x minus 2 minus this ln x squared minus 2x plus 2 minus arctan x minus 1 plus c. Plus c because we had an indefinite integral here. So we took integral of our first term, that was 2 ln x minus 2. To get the second term, we did some finagling with the numerator here. So remember that you always want to try to get one of the terms to be exactly the derivative of the bottom, because then you'll get an easy ln. After that, anything that's left over is usually a separate integral that's also not too difficult, and that was the whole purpose of how your teacher wrote this problem, is that you already did that part in part E. So anytime you get a constant over a quadratic equation, you should immediately be thinking this is going to turn into some sort of arctangent. And we showed the method how to do that here. So the last thing to be careful about is in getting the numerator of this to be exactly the derivative of the denominator, we ended up taking out a negative sign. And remember that then this entire integral, the second part, had to be subtracted from the first. So it's very important that you have negative signs there. And plus c because we have an indefinite integral. So partial fractions problems like this usually will take a while. But they're going to be broken down step by step, so you have a lot of chances for partial credit and things like that as well.
The Teaching Center. UF's Learning Support Center, www.teachingcenter.ufl.edu.